I'm going to solve this using some elementary trig identities. In order for p of x to be equal to 0, then the real part of p must be equal to 0, and the imaginary part of p must be equal to 0. Let's start with the imaginary part. This is everything that has I as a coefficient, and we want this expression to be equal to 0. I'm going to keep the sine of 2x as is for now, and I'm going to use the trig sum formula for sine, dividing this 3x into 2x plus x. So this is sine of 2x times cosine of x, and sine of x times cosine of 2x. Looking carefully at this last term, sine of x times cosine of 2x, I can write cosine of 2x as 2 cosine squared x minus 1. When I multiply it by the sine of x, I get 2 times the sine of x times the square of this cosine of x. Over here, I again have the sine of 2x. So let's leave everything else the same for now. Sine of 2x times the cosine of x, rewriting cosine of 2x as 2 cosine squared minus 1. Multiplying this first term, I'm going to have another sine of 2x times the cosine of x minus sine of x. This is great news because I have sine of x minus sine of x is equal to 0, and I have 2 of these terms. Now I have 2 terms with sine of 2x, which I'm going to factor, and I have 2 factors whose product is 0. That means one or the other is equal to 0. In order for sine of 2x to be equal to 0, 2x is going to be a multiple of pi. X is going to be a multiple of pi over 2. On this interval, that restricts x to 0, pi over 2, pi, and 3 pi over 2. Cosine of x is equal to 1/2 when x is equal to pi over 3 or 5 pi over 3. In order for p to be equal to 0, we also have to have the real part equal to 0. The real part of p is 1 plus cosine of x minus cosine of 2x plus cosine of 3x. Let's try these solutions that we got for the imaginary part and see if we can generate 0 for the real part as well. When x equals 0, we get 1 plus cosine of 0 minus cosine of 0 plus cosine of 0. This is equal to 2. We need the real part equal to 0. We'll try x equals pi over 2 next. Plugging in for x, cosine of pi over 2 is 0. Then we're going to subtract -1 and add 0 again. This gives us 2. Let's try x equals pi. We're going to add -1 and subtract 1 and add -1. This is equal to -2, which is not 0. This is 0 minus -1, and this cosine is 0. This is 2 again. Let's try this other side where x is equal to pi over 3 and 5 pi over 3. Cosine at pi over 3 is 1/2. Cosine at 2 pi over 3 is -1/2, so subtracting -1/2, and then this is -1, and so is the sum. Let's try our last solution, 5 pi over 3. Cosine of 5 pi over 3 is 1/2. Cosine of 10 pi over 3 is the same as the cosine of 4 pi over 3, so that's minus -1/2, and then this cosine is -1, and this is equal to 1. None of the solutions that make the imaginary part of p equal to 0 simultaneously make the real part of p equal to 0, so therefore there are no solutions.